Okay, today we're doing a few review problems for Chapter 7. So this is, and the Chapter 7 test is tomorrow, by the way. So this is just a simple skill. You just got to know how to graph these things. These are rational functions. And the rational part means it's a fraction function. And it'll be a little bit simpler once we factor it. X plus 5 and x plus 1 over x plus 5 and x minus 5. And that cancels that, which makes a whole. And the whole is at -5, but you can't just say -5. That's what you could do in honors higher algebra, but we need you to find the exact spot where the whole is. So how do you do that? If you stick the -5 in here, it's going to crash. The denominator is going to be 0. So how do you do it? Yes, sir. Stick it in what's left. Exactly. After this thing crashed, stick it in here. And now -5 plus 1 makes -4 over -5 minus 5 makes -10, but that can reduce a lot. So it turns into 2/5, and then it's positive 2/5. Right? Raise your hand if you had that one right. Okay, good. So positive 2/5. So that's exactly where the whole should be on the graph. All right, now the verticals are what's left in the bottom here after the whole's canceled, because you can't be a whole and an asymptote. So it's x equals 5 is the vertical asymptote. The horizontals are the horizontals, y equals things. Remember that? And the x equals are the vertical asymptotes. But anyway, the horizontals are the y equals things. Is this a bigger on bottom, bigger on top, or same on both? Same on both, and therefore it's a ratio of the lead coefficients, which are 1 and 1. And therefore y equals 1 over 1, y equals 1. Okay, cool. And then graph it. So I'm going to transfer this information over onto a screen I have in my classroom. And -5 and 2/5. And then I'll be able to go to my next page and actually graph it. So you should probably have an asymptote at x equals 5. And you should probably have an asymptote at y equals 1. And you should probably assume it kind of goes like this, but you don't know for sure until you check the xy chart. So I make an xy chart. And what are some points? Well, there's one point on it for sure. That's the whole. And that's at -5, 2/5. Now, you could argue that shouldn't be on the chart because it's a whole, but if you just put whole after it, that would remind you to put a whole there. All right, so -5, positive 2/5 would be -5 goes over here, down, no, up 2/5 is 0.4. So that's about here-ish. And that tells me, oh, it's probably kind of like this. Exactly where? I should get another point or two. Maybe I should get 1 point over here in that 2, 3 kind of zone. So I'm going to put in 3. So I put in 3 into my function. It's the resulting function after things canceled was x plus 1 over x minus 5. Thank you. And that, once I put in a 3 into it, becomes 4 over -2, which makes -2. 3, -2. And I missed it, but it was right there, so I'm not too far off from it. So there we go. All right, now my graph's a little bit better. And now you need at least 3 points. In fact, you should probably have 4 or 5, but I just don't want to have to mark somebody's wrong if they got 3 really good points and the graph looks good. So I'm going to make one more point for sure, and that's past 5. So how about I pick 6? If I put a 6 into my function, I get 7 over 1, which makes 7. So 6, 7 means there's a dot like right there. So it looks something like that. I want to make my graph look really professional. I should pick something else, like maybe put in 7. And if I put in 7, I get 7, which is 8 over 7 minus 5 is 2. 8 over 2 is 4. 7, 4 over 7 up 4. Okay, so I was off a little bit. Adjusting my graph, it's a little more like that. All right, good enough. Raise your hand if you understand that concept. All right, good. Let's move on to something else that takes a lot less time. On this, you just need to know the roots, the zeros, the x-intercepts. They're all the same thing. And then the things that make it crash, which would be, in this case, the asymptote. Those two things, basically the things on the top and the things on the bottom. Things that make the top 0, which are called zeros. Things that make the bottom 0, which are things that make it undefined. Sorry, that's me. So I'm going to find those two things, put them on a number line, and then see if you know how to finish this one. All right? You can leave the answer in number line notation. I'll pause for a second while you do that. So we're back, and you should have picked that -1 is a thing. We don't know exactly what it does right this second, but we know that -1 is important. Now let's analyze it a little bit more. -1, when you actually put it in, makes the top 0. And so that means the whole thing is 0 as long as the bottom doesn't disappear, which it doesn't. So if I put in a -1, I get 0. Is 0 greater than or equal to 0? Get out that sign right there. That part, equal to part, makes it work. As opposed to the other one, which is when you put in 5, it's also an important thing. That one doesn't work. It doesn't equal 0. It makes the bottom 0, which means it's undefined. So you should put a U above this and a Z above that. I know it's a little different than you're maybe used to, but that's what they want you to do in calculus. Take a wild guess what Z stands for. 0. And how about U? Undefined. Okay, good. Sometimes people put an asymptote line through those too. You don't have to do that, but I'm just trying to show you where you're going for the future. Okay, next is testing regions. If I test a number bigger than 5, like 6, and I stick it in here and I see what happens, I'll have 7 over 1, which is 7. And that's positive. Some teachers don't even get the actual answer. They'll just say a positive over a positive makes it positive. And the positives are bigger than 0, so it works. That's a good way to do it too. You don't need to get the exact number. I made the function easy enough that you can get the exact number pretty easy. But test 0. I put in a 0 and a 0. And I get 1 over -5 makes -1/5. Is -1/5 bigger than 0? No, it's not. So therefore, it doesn't work in here. And then the last one, I'm pretty sure it works out here. So should I just shade it in? No, I need to test something. I'm going to test -2. And let's see if it actually works. This makes a negative over a negative, which makes a positive. A positive is bigger than 0, so it works. Yay. Okay. And you could rewrite that in interval notation if the test required that, or set builder notation if it required that, blah, blah, blah. But you could write it just on a number line if it doesn't tell you any other format. Okay. Now let's talk about the tougher ones, the word problems. So this one is just a simple, super simple piece of wire that's X inches long. You don't know how big it is. It's just a piece of wire. And it got bent into a circle. Do you get that that kind of makes the circumference of the circle? All right. So whenever you have a word problem like this where they ask you to like make a thing, then sketch it. So would you please make the sketch? But you need to sketch it and label it and think about it. Is that enough right there to find me all the things you usually find about a circle? Like it's, well, it is its circumference already, but also the area of the circle. So you probably need the radius then, so you better figure that out. So the question is, if you have a piece of wire of unknown length, we'll call it X, what's the area of the circle? Of course, you don't know unless you tell you X, but you can give the answer in terms of X. So your answer is going to have an X in it. Now, these can be confusing, but you always have a picture, and then you can go back to formulas. You need to know a formula about circles. In fact, you need to know 2 of them. I know some of you don't, so let's help people a little bit. First, you're going to need the circumference formula. Does anybody have it down? Yes, sir. Pi times diameter is correct, or we could replace the diameter with 2 r's, 2 radiuses. Did you get that on the ACT test? They would not tell you that. They would expect you to know it. One of those little formulas you better have memorized. Okay? And then what I asked you for was the volume in terms of X. Do you get that? Therefore, you need the volume formula. I'm going to write that over here. Do you have the volume of a circle figured out? Oh, sorry. I said volume, and that's really dumb. Area. Sorry. This is not 3-dimensional. Area of a circle. Sorry. And what is the area of a circle formula? Pi r squared. All right. So now, I guess you're going to have to figure out how to draw your picture and label it well. It doesn't have all the labels it needs. And then you're going to need to take the stuff from the picture and stick it into the formula. That's my process for you of how to solve word problems. Make a good picture, label it well, stick the stuff from the picture in the formula. You'll be able to tell me the volume in terms of x. Volume in terms of x. Okay, I will pause for a second. Let me try that. Is there any questions, clarifying questions on that? I keep saying volume. Yes, area. Sorry, area in terms of x. No, you can't find a volume unless I told you that this was the bottom of a silo, for instance, and then there was a height of the silo. No, we don't have a third dimension here. All right, sorry about that. I'm going to pause while you give that a try. All right, so first off, circumference equals 2 pi r. Great, Mr. Server. I got a formula. What the heck am I supposed to put in it? Well, the only thing you can put in it, which is that, which is really what? Circumference is x. So I'm going to put an x right here. X equals pi to r. How does that help me? Well, I can find the radius then. What's the radius equal to? Well, I'm going to solve for r, and I divide by 2 pi. Divide by 2 pi. Why did I do that? So I could label this thing. That's the radius, and it's equal to what? X over 2 pi. Do you get why that's important? Because to do anything with a circle, you pretty much need its radius. Okay, so then I got to go over to the other formula and stick stuff from here into here. Am I told the area? No, so that's still a. And pi is just pi. And it just comes down to r. What is r? We just figured it out. X over 2 pi. And then I square it. Now I'd like you to simplify that all the way. Since some stuff can cancel, but you better be careful to do things in the right order. Simplify it all the way. I'm going to pause for a second while you do that. Agreed. First, we should square everything. Okay, so we're going to square that stuff. So area is pi times x squared. And how do you square 2 pi? 4 pi squared. A lot of people are going to forget to square the 2, but we did it right there. So now I can cancel some stuff. What cancels? So I can go doink, doink. No. Pi squared turns into just pi. It won't be pi squared anymore. Because down there's really pi times pi. We cancel off one of them. Okay, good. So area equals x squared over 4 pi. That's the area in terms of x. How many think you could have done that? Okay, good. So here's another question. It's more of a rate kind of a question. My grandpa liked to pick seashells from the beach in Florida. We timed him, and in a 2-hour walk, he picked up 25 shells. He was pretty choosy about them. He would pick like just the ones he really liked. He had one of his favorite was the turkey wings. And if you've ever been to Florida, have you seen the shells that are kind of long and they have they're kind of brownish? And anyway, he would usually make those into these little birds. He'd take 2 of those, glue them together, and then he'd glue some other shells together. Anyway, he'd make little cool things out of them. So it's something I remember from Florida back when I was a kid. And my grandma also liked to pick shells, but she was less choosy, and she'd pick about 30 shells per hour. If they went on a 2.5-hour walk together, how many shells would they pick? Remember, we've got a system for this. Rate plus a rate equals a rate. All right, figure it out. I'll pause for a second and give that a shot. Okay, here we go. You should have said 25 in 2 hours plus 30 in 1 hour equals, and this is the part that feels weird to me, but it will equal their combined rate. Instead of just finding x and then knowing their combined rate, let's just actually do the problem all in one fell swoop, which is now they're going to go for a walk for 2 hours. And so where should 2.5 hours, so where should that go? On the bottom. So 2.5 goes here, and we put x there, and then we won't be finding their rate. We'll be finding their rate for 2.5 hours. So that's better. So then if you set it up that way, you would just have to multiply everything by 5 and 2.5, 2 and 2.5, which is the same as multiplying everything by 5, but it's actually smarter to do this. Why is this any smarter than multiplying by 5? because then this can cancel this, and that can cancel that. And this one is a 5 times 30 is 150. Notice me not needing a calculator. 2.5 times 25. Well, 25 times 2, I'm splitting it up into 2 plus 0.5 times 25. 25 times 2 is 50. 25 times a half is half of 25, which is 12 and a half. So that's 62.5, I think. I don't totally trust myself, but I think that's right. Equals 2 times x is 2x. Cool. So then this is 212. I got that right? 0.5? And then I split 212 and a half in half, and I get 106.25, but then let's just call it about 106 because you can't have a quarter of a shell. I've done it before. A little piece of a shell that was really shiny and cool, so I picked it up. So it could happen. Raise your hand if you had that one right. Okay, good. So now, I think we need to take a break from what we're doing, and I'm going to pause for a bit while we take a break. Okay, let's see how we should have done the 2 remote controls cars problem. We knew that Jeff's distance was unknown, so we put a D there. And his rate was 60 and his time was T. Seems like we're just putting variables all over the place. How could this still come out? Because we're going to have 2 equations and only 2 variables. And if you've got 2 equations and 2 variables, you can solve for one of the variables and stick it in the other equation. Like here, look at it's already solved. D equals 60t. So wherever there's a D in the other equation, you're going to stick in 60t. And then you'll only have t's in that equation. All right, so let's finish it. And L, I cannot just put D. Why can I not put a D right here for Lori's distance? Yes? It would say that the distance was the same as Jeff's. Or is it actually the same distance? No, because they're going different speeds. One's going to go farther than the other. So I can't put a D there. I also know this weird 800 number. So who figured it out? Yes, sir?
It will be 800 minus D.
You are correct. Explain it.
Well, 9 would have to equal 800.
Yeah, that's a good way to say it. Together, if you add this and this together, they'll add up to 800 now. Another way to think of it is, whatever D was, I don't know what it was, but let's say it was 100. Then wouldn't this other one have to be 800 minus 100? That makes sense? All right. So that's the main skill you got to get used to is how to write those. This is, again, just given. It's easy. It's 100. And then this time. What do we know about the time for Lori's car? Compared to Jeff's car. Same. If they both start at the same time and they both hit at the same moment, then their time has got to be exactly the same. So T. And there you go. You got 2 equations with only 2 variables, D and T. And we just said a second ago that D is equal to 60t, so I can right there put in a 60t, and then I can solve for t. Sir? To be honest, I don't know. I'm not sure it would work. Does it come out the same? Okay. Is that always going to work for every problem? No. And that's what you're acknowledging. This is the skill you'd need because all the problems could be totally different. They could have said, Jeff releases his car 1 second after Lori starts, and you could still do it with this style. So, okay, cool. All right. For tonight's homework, listen close. You do not have any homework, but I am posting some practice word problems and the key for them. Do as many as you wish. Okay? Practice problems will be posted. Look under today's date. Have a good day.